All right, ladies and gentlemen, we're going to continue with our lecture on what? Probability. Okay. And I guess we looked at all of these different what? Experiments. We looked at the sample space, if you guys remember. And now I'm going to start off today by giving you the definition of what? Probability of an event. Okay? Event E. Okay, you guys okay with this? Alrighty. Here's what I'm going to say to you guys. I'm recording this lecture on the iPad. Hopefully it'll come out. I hope. And then I could put it in Canvas for you guys. But, that's what I'm trying to do. So we'll see how this works. Nevertheless, let's give you guys the definition of probability of an event. Okay? So here we go. It's going to be the number of outcomes in the event to the number of outcomes in the sample space. Okay? So you're going to have two numbers here. You got a numerator. You got a what? Denominator. Okay? You guys okay with that? Now this is function notation. So this is the event here called E. And this is the probability of the event. Probability of E in words. Okay, so there we go. So what I'm going to do now here is this. As my first example for you guys, I'm going to say, we're going to go back to the idea that you roll a die here. Okay? That's your experiment. You're rolling a die. And now they're going to ask, what's the probability of rolling? Here we're going to go through some events now. Okay? Here's some events. Now, let me go back and double check. Oh, we didn't give you an event. Okay, we have to give you the definition of an event. Okay, good. That's fine. So what's the probability of rolling? I'm going to say a 4. Okay? And then question 2, I'm going to say a 1. And then question number 3, I'm going to say a 2 here. So far, so good? So we need to know what an event is. Everything that I'm showing you guys here is an event, but I have to give you that definition as well. Okay? So, all right, let's tell you what an event is. You're really looking at it. An event, E, is any subset of the what? Sample space. This is what we call an event. It's a subset. What's a set again? It's a list. What's your sample space? S. So it's a subset of the sample space S. Okay? Now, you might say, what is a subset? Well, here's a subset here. draw a picture of a Venn diagram for you guys. Okay? So here is every outcome in the sample space. We'll call that S for you guys. E is contained in S. So we say E is contained in S. Any subset of the sample space. So for your experiment of rolling a die, do you guys remember? What's your sample space when you roll a die? What was the experiment? What is S? You roll a die, what's S going to be?
The amount of possibilities.
Nope. Nope, you need your sample space. Rolling a die, it's in your notes. You go, did we take any notes on that? Yes, we did. What's the sample space? When you roll a die, there you go. It's a list of all possible outcomes, okay? So what are the outcomes? 1, what else? 2, 3, 4, 5, and what? 6. We're going to put all this together. Okay, so you're going to roll a what? A 1, a 2, a 3, a 4, a 5, and a 6. There you guys go. So here's our what? Sample what? Space. Okay, easy peasy lemon squeezy. Okay, so we wrote this down yesterday. Here's the sample space. So today, we're looking at the definition of a probability. This is what we're going to do. But we have to understand, what do they mean by an event here? So the first event, when you roll a 4, tell me what you guys think here. So number 1 here. My event is a set itself. It's E here, okay? What you have to do is go back to the sample space here. It's right in front of you. Which outcome is the 4? Anybody have an idea? Which outcome is 4?
4.
What is it?
4.
4. So ladies and gentlemen, there's your subset. You list the what? The 4. You guys okay with that? Is that easy?
Yeah.
Okay. Now, could you guys tell me what's the cardinality of this event? How many outcomes are here? In this set right here, how many outcomes? In E, right, here's my event E. How many outcomes are here? 1. Good job. Yes, N of S is what? N of S is going to be what? How many outcomes are in the sample space? 6. So, ladies and gentlemen, you're right about that. N of S is 6. However, N of E, in this case, you're rolling a 4. There's only one 4, so this is 1. So what's the probability then of rolling a 4, ladies and gentlemen? You're going to use this definition. N of E over N of S. This is the definition you guys use. So the point I'm making is this. You have a numerator, which is what number? 1. And you have a denominator, which is what number? 6. Ladies and gentlemen, the probability is what? 1/6. Okay? So you're looking for 2 numbers. The number of outcomes in the event and the total number of possible what? Outcomes. That's it. You're counting outcomes. What do you guys think? Is that easy or is that hard? Okay, well, let's see. What was the next question? What's the probability of rolling a what? A 1. Now, in terms of an event, we've seen the first one. This is the 4. What is this? And then what is this? You have to know which number is 1? So go back to your sample space. Which number is 1 in the sample space? What is it? Right here. Isn't it 1? Does that make some sense? Okay, so let's see what this probability is. What's in that set? Just the what? 1. How many outcomes are in here? 1. So what is the probability, ladies and gentlemen? What's the probability? I got news for you. I know my denominator. What goes in the denominator again? 6. There's 6 outcomes in the sample space. How many outcomes consist of the 1? 1. There you go, ladies and gentlemen. Now you're what? You're done. So the chance you roll a 1 is 1/6, because there's 1 out of the 6 outcomes. Does that make any sense? All right. What's the next question? So this is the 1. Which outcome in the sample space is 2? Is it 2?
Yeah.
Okay. There you go. So what's this probability going to be? Number 3. Chance you select a 2. What's that going to be for E? It's only the 2 here. Okay. How many outcomes consist of being just 2? 1. What's the probability of rolling a 2? 1 out of 6. Okay, so what you guys have just done has been answering these probability questions. Okay, so each one of these answers is what? Is 1/6. So probability is a fraction, ladies and gentlemen. Each one is 1/6. Okay, give you guys another example. What if they say, what's the probability of rolling an even number? So you're going to have to go to the sample space, okay? And you're going to have to tell me now, in the sample space, which numbers are even?
2, 4, 6.
2, 4, what? 6. Is that true? So let me write this down for you guys, okay? As a set, we have what? 2, 4, 6. Did you guys know something? I got 8, I got 10, I got 12. You guys know there's a lot of even numbers, aren't they? But remember, how do we define an event? It has to be a subset of the what? Of the sample space, okay? An event is a subset. What's a subset? It's a list within a list. Now, that's a very formal definition, but here's what this really means. When they ask you a question like this, a probability question, I don't have to list what? 8, 10, 12, 14, and 16. Do you guys know why?
They're not in the subset.
They're not in the sample space. It's not a subset. Yes. So that technical definition, people go, oh, subset of the sample space? It's like saying it has to be in the context of the sample space. You're not going to put a what? A 10? Yes, 10's even, but that's not an option when you roll a die. Is that right? The only options when you roll a die, this is why you always go back to the what? The sample space. These are the only even numbers. 2, 4, 6. Okay, you guys understand that idea? Okay, now, how many outcomes are even? How many outcomes are even, ladies and gentlemen? What's N of E?
3.
Good. Good job. So then the probability of rolling an even number, okay, what's your definition again? This is a probability definition, ladies and gentlemen. If you're thinking of getting a tattoo this weekend, that's what you're going to get. You guys know what I'm saying? Anybody going to get a tattoo this weekend? You want to get this one. What do I really mean? Where do you want to tattoo it? To your brain. Good. Good. Okay. Because very often when students come to me and they say they have questions and they don't know what to do, they go, oh, Mr. Judge, I don't know how to answer this question, right? I say, okay. And then I said, let's read it. And then we read it. And it says, what's the probability? And then I don't give answers really. Okay? I don't give answers. What I say to people is, okay, what's your definition? And you want to know what happens every single time? I don't know. So well, there's your problem. You don't know the what? Definition of probability. And so I actually make them search for that definition in their notes. I don't give it to them. Why not? Why don't I do that? Because Mr. Judge is mean. Is that right? Yes. So why won't I give them the definition? Because I want to make sure they're what? At least at least they're doing what? Are they taking their notes? I mean, do you guys know? There's nothing anybody could ever do to you to help you to learn if you're not doing your part. It never will happen. Never happens. Trust me on that one. It's simple logic. So I ask people, what's your definition of probability? I expect you to know it. Because if you don't, that should tell you something. You know what happens when you give people things too easy? What happens?
They don't appreciate.
Yeah, I mean, it's not, yeah, they don't appreciate it, but also, too, in a learning context, they don't learn. It's that simple. So I'll say, what's your definition? What do I expect? N of E over what? N of S. Then I ask another question. Okay, now that you got your definition, how many outcomes are in the event? 3. Okay, good. Then I ask another question. How many outcomes are in the sample space? 6. I say, okay, then what do you think that is? And then what do you think people tell me? They'll say what? 3 over 6? And I say, yes. And then they say, do I have to simplify my fraction? And I say, what? Yes. And what do they say? Okay, it's 1/2. Is it 1/2? Say, yes. And they say, is it that easy? And I say what? Yes. And there it is. You guys see what I'm saying? And that's how you what? Learn. If you don't go through the process, you're not going to what? Learn. And that's really what sometimes people do. They tell themselves they can't learn, but they never even did their part. Did you guys see what I mean? That's how it works. And that's sad. So, okay. And how do I even know this? I used to do it myself. That's how I know. So if I ask you guys this question here about a probability, right? Probability of an odd number. What's the process, ladies and gentlemen? Do you guys know? What do you got to go back and do? Go to the sample space. And here's going to be where people have an issue. Right? Which numbers are odd? 1 is odd. What else? 3 is odd. What else? 5 is odd. Do I list 7? No. Do I list 9? No. Why not? They're not in the sample space. Do they have to be? Yes. That's the only way you can answer a question, because the definition of an event is any subset of the what? Sample space. It has to be in the sample space. Is that easy? Okay, well, let's think about this, right? What were the odd numbers in the sample space? 1. What else? 3. What else? 5. What's N of E? What's the cardinality of that set? 3. Good. Think of the grocery list, right? Can you get in the express line counting your groceries? Good. All right. We're almost there. What's the definition of a probability of an event? Remember this? It's the number of outcomes in the event divided by the what? The number of outcomes in the sample space. Does the sample space ever change for rolling a die? No. So all of these questions, you guys notice, has the denominator of what? 6. That's why I put it in what? Red. What's the numerator in this example going to be? What is it? 3. What's 3 6? 1/2. Doesn't that do you have to reduce every fraction? Yes. So take a look, ladies and gentlemen. You guys are answering probability questions. I wish I had my applause. Like I said, I'm recording the lecture on the iPad, and I'm going to try to upload it when I get home because I'm trying to upload it now between classes, but it's compressing the file. I don't want that file compressed. I want a big file so it has what? You can see it. If you compress it, it's like watching it on your phone or something. I don't know. I've never tried it. This is the first try of sending you guys a video recording on the iPad. I talked to Apple last night, and they're no help. They're like, they're no help. You're like, oh, you're doing everything right. And I'm like, I know I'm doing everything right. I'm not doing anything weird with this stuff. I'm using the ports you guys design and all the products you recommend, and it's all done right. So they couldn't help me. They go, you can try to record on your iPad. I go, yeah, but I need a big file size, and I got to stream, and oh yeah, you can't do it that way. I go, yeah, I know. If I could, I would have done it. So they weren't very helpful. So okay, is that interesting? That's interesting. Now I'm afraid. You guys know what I'm afraid? What if I buy a nice big computer? You know what I'm going to have to buy? The extended warranty. Because it might get zapped within 4 months. I guess I'm too hard on my what? On technology. Not really.
Have you ever considered getting a different, like not Apple?
No. I mean, even the software I use to stream is native to Apple.
Oh.
It's not even like a generic one. It's like, no, they design it specifically for your computers. And then they try to tell me, you know what it is. What is it? It's because you're using the new silicon chip. I go, no, and that 13-inch iMac Pro is an Intel. They said, if it was the Intel chip, it wouldn't be doing that. I said, no, it has the Intel chip. It's the old, 13-inch MacBook Pro before they switched. It's like, oh, that's not it. So if I buy a new Intel silicon chip, you're going to tell me it's going to crash on me like that? Really? Why would I spend $4,000? I'd rather go to Maui. You guys see some critical thinking skills here? You guys know what I mean? I'd rather go to Maui. I'm going to buy a silicon chip that's going to crash in 2 months. Doesn't make sense. Anyway, so we're going to try doing this here on the iPad. Yeah, I already had that recommendation. Some student said use this other, whatever it is. I don't know. Never heard of that, but I don't know. We'll see. I just now have to figure out how do I get that video, from the iPad to Canvas without compressing. I don't know. Let's see. Okay. I digress. Let's have you guys try something. You're going to roll a number. at least a what? 2. You're gonna roll a number no more than 2. 8. You're gonna roll a number less than, less than what? 5. 9, you can roll a number between 2 and 5. And I wish I had my timer. I don't. Oh, I think I do have a timer, but I don't want to touch this stuff. Do I have a timer? Where's the timer? Yeah. Let's give you 4 minutes. Oh, but now you can't see the questions.
You can go back.
I can go back?
The timer will still be running.
Really? Okay, hold on. Oh, you guys know what you're doing. Resume. Where's the timer?
It doesn't show.
It doesn't show. Okay, well, we'll hear it.
I guess there's no way that I can see the list because I didn't get the beginning and the notes, so I don't know what the numbers are.
Well, you're gonna have to make the list here for these questions. Put S is 1 through 6. It's rolling a die. So it's the rolling of the die. So S will be 1 through 6. Yeah, there's your sample space. Yeah, because it's rolling a die. Now for all of these here, you have to tell me what numbers are at least 2, what numbers are no more than 2, what numbers are less than 5. Okay.
I'll still be doing every day when we had them.
Hmm?
When we were doing this.
Yes, it's language. Yep. Let's go back to the language. Yep.
Look how neat my language looks.
Yes.
That's the one thing that I did get a little bit.
There you go. Well, we're gonna see it again. There's the timer. Okay. Now remember something here, ladies and gentlemen. Remember, are we rolling a die? Say yes.
Yes.
Okay. What's the sample space? Isn't it right here? Okay. Don't I need this information? Alrighty. Now, remember, I wrote a little worksheet for us titled what? Language. You guys know what I'm saying? Language and process. So you have to know the meaning of what? What phrase? At least what? What does at least two mean? Two or, three or, four or, five or, six. This is my event. Is that true? Okay, you guys okay with that? Okay. Now what do I do in the process? If you wanted, yes, you can say what? You can say E for the event is what? 2, 3, 4, 5, and 6. And then what else can you say? What is N of E going to be? 5. Is that true? Okay. We're answering probability questions. So what's the probability of rolling a number that's at least 2? 5 out of 6. Good job. There you go. Did you get the tattoo? Hopefully. It's what? It's 5, 6. Is that right? So do you guys see how language is associated with these questions? That's why I did what I did and gave you guys a language worksheet. Okay, you guys okay with that? All right, let's go back now again and let's use more of our language. What do you guys know about this here? What's the phrase no more than 2? What does no more than 2 actually mean? It means 2 or what? Less. Okay, which outcomes are 2 or less? The 1, the what? Okay, what's N of E? 2. Good job. Okay, you guys okay with that? So now, ladies and gentlemen, what's the probability going to be? 2 out of? 2 out of what? What does that reduce to? There you go, ladies and gentlemen. So the denominator, notice, is what? 6 is what? 6, but it reduces to 1/3. So there you go. That's what you're going to need to do. Easy peasy lemon squeezy. You guys see what I'm saying? Okay. Yes. Language. Less than 5. Okay, which outcomes are less than 5? You got to know what less than 5 is? What's less than 5? 1, what else? 2, what else? 3, what else? 4. Is 5 less than 5? No. So what are you guys going to do? You can say 1, 2, 3, and 4. How many outcomes are here? 4. Is that right? What's the probability definition? 4 out of what? 6. What does that reduce to? 2/3. So, ladies and gentlemen, there you go. The answer is 2/3. Okay? All right, you guys okay with that? Easy peasy, lemon squeezy. These are your probability questions here. Okay, good. Let's go back and say, where are we at? What's number 9? Oh, here we go. Number 9, between what? Between 2 and what? 5. Okay. Do you guys remember between 2 and 5? Wasn't that inclusive? 2, 3, 4, 5. Those outcomes, aren't they between 2 and 5? Including 2, including 5? Okay. 2, 3, 4, 5. So in your event, you're going to say what? 2, 3, 4, and what? 5. What's N of E, ladies and gentlemen? N of E is what? 4. What's the probability? And what does that reduce to? 2/3. Okay, so notice in the definition, you need to know about the sample space, don't you? Because it's in the definition of a probability of a what? Of an event. Okay? You guys okay with that? What do you guys think? Is that easy or is that hard? I don't know. Let's see. Should I give you guys another example here? I'm going to give you guys some examples about how to do this. Let's see here. Let's go back to the sample space when you have what? What happens if I say you're thinking of having a child, okay? You're going to have a child. They're going to say, what's the probability of having a boy? Right? What do you have to go back to again? You got to go where? What's your sample space? It's in your notes. What's the sample space when you have a boy? What's in the sample space? What's the definition? The list of all possible outcomes. Okay.
When you have a boy, when you have a baby.
Oh. Well, what's the experiment? You're going to have a child. Right? What's in the sample space? Is that true?
Yep.
Right? Wasn't that in our notes? We said you have a child. What could you have? Boy or girl? See, here's the thing about probability. Like, it's very simple, but what's the problem? Maybe people aren't thinking of it this way. When you have a child, you can have a boy or you can have a what? Girl. Okay, you guys okay with that? What does having a child mean? You're having what? One child. Is that true? Okay. Is that kind of simple? All right. What's N of S, by the way? 2. So what do we actually mean by that? Here's what we mean. If you're going to have a child, there's going to be 2 possible outcomes. Okay, you okay with that? For the gender. 2 outcomes. We're going to keep it simple. We're not talking twins and triplets. What if I have, Mr. Judge, 6 kids? We're keeping it what? Simple. What's that called, having 6? Sextuplets? You guys know what I'm saying? I think it's 6. So sometimes people do that to themselves. What if I have triplets? No. We're keeping it what? Simple. What if I have twins? No, we're keeping it what? Simple. Okay? So if you're going to have a child, just keeping it simple, the gender is going to be a boy or a girl, so there's 2 outcomes. That's it. Now, you say, they're going to ask me a probability question. How do I know? Because what does it say? What's the probability? So what's the probability of having a what? Boy, what's this? What is this statement? This is my event, ladies and gentlemen. The event is having a what? Boy, how do I know? Because they wrote it down and they asked me. So go to the sample space and tell me which outcome consists of having a boy. What do you guys think? Which outcome consists of having a boy? Huh? No, I'm before that. Which outcome is for a boy?
Boy.
The B. Okay. It's just reading your list. Okay, what now? How many outcomes are there? 1. Good. Is that the probability? No. What's the probability of having a boy? This is P of E. Remember your definition? Number of outcomes in the event out of the total number of outcomes. Oh, what's that probability? 1 out of what? 2. So do you guys know 1/2, by the way? You ever hear that phrase? The chance of having a boy is what? 1/2? You guys know what I'm saying? What else have you heard? 50-50. Now let's think about what this means. What's the decimal representation of 1/2? Do you guys know what it is? And I have a calculator here. Okay, you're saying, I don't know, where's my calculator? There we go. It's just kind of like the TI. 1 divided by 2 is what? Where's my enter? Can you guys see that all the way to the right? What's that decimal? 0.5. Good. So 0.5 written as a what? What is this as a percent? 0.5 can be written as a percent. Do you guys know what that is? 50 what? Percent. So this is the probability being 1/2 as a decimal being 0.5. But in language, we use the phrase 50%. The language portion. So you might say, oh, what's the chance of having a boy? Well, you got a 50% chance of having a boy. If you listen to the weather and the news, is it supposed to rain tomorrow? Oh.
Yeah.
What's the chance? Don't they say percent? Yes. So this is a 50% chance of having a what? A boy. That's where it comes from. Let's note, see if you're awake. Say by the way or note, yeah. Let's note. What's the probability of having a what? What's the probability of having a girl? It is the same. But let's see. This is a probability question. Is that right? Probability. And then chance of having a what? Girl now. Okay? So let's go through the process. My event E, just so you guys know, go to the sample space again. Here's my sample space, the list of all possible outcomes. Which one of these outcomes consists of having, or which is the girl, is what I'm saying? The G. Is that true? Okay, good. So you know what I can do? I can say, okay, this is going to be what? G. How many outcomes are there in that event? How many outcomes? 1 outcome, 1 G, 1 girl. Is that true? So what's the probability of having a girl then? I wish I had my buttons. 1 out of what? 2. Good. This is a probability value. That's a legitimate answer. 1/2. What else can I write down as an answer? 0.5. Good. This also equals what? 50%. So all of these answers are the same, but you know, you can give 1/2 as an answer. You keep it simple. You could give 0.5. That won't mark it wrong because it's the same. You could even do 50%. You say, well, why do I need to know this? Because language, you can say there's a 50% chance of having a what? Girl. There's a 50% chance of having a what? A boy. So sometimes, and I'm going to go even further, sometimes those chances are the same. They're equal. You guys know what I'm saying? 50% chance of having a boy, 50% chance of having a girl. And that's kind of the easiest example anyone can ever give you as a probability question. There's nothing easier than that. Hey, what are you talking about? Yeah, that's kind of like the starting point if you can ever start there. Because what we also have here, give you guys a definition. You guys want to know this definition here, okay? We say, this is a definition of what we call equally likely. Because we need more language here, okay? Two events, we'll name them E and F, are equally likely, okay? If the probabilities are what? Are equal. So you guys want to write down that definition as well. Two events. You say, what are the events? E, what else? F, okay. So E and F are what? Equally likely when the probability values are the same. There's an equal sign. So this is an example of that situation. The chance of having a boy is 1/2. The chance of having a girl is also what? 1/2. They are said to be equally what? Likely. Yes. Because they have the same probabilities. Okay. Equally likely. This is about language communication in relation to the, to the computation. So here's kind of the thing about it. This is what I was having a discussion with somebody before in my office about math and all the, stuff that's going on and everything. Is that, math and language are so intimately related. That's where it comes from. It comes from language. It just didn't fall out of the sky as some arbitrary abstract thing that everybody hates. It came from language. You guys know it's a language thing. So when you say, well, what are you saying? People are walking around without communication skills? Oh, yes. Oh, yes. 100%. Yes. It's a source of a lot of problems. Miscommunication. Do you guys know what I'm talking about? No? You guys don't know? Miscommunication? It's not a problem to have miscommunication? There's a lot of problems. So you're learning definitions, language, process, probability, and there you guys go. So now that you have that definition, go back to your examples here. Can you guys tell me anything about being equally likely? Which events, when you roll a die, remember this idea we started this morning with? You roll a what? You roll a die, ladies and gentlemen. Which one of these events are equally likely? Can you apply the definition?
An odd or even?
Yeah. Exactly. You can either roll rolling an even number has the same probability as rolling a what? Odd number. Is that true? How do you know? They're both what? 1/2. Is that true? You're looking at it. These two are said to be what? Equally what? Likely. Yes. Nice. Oops. I wanted red. Okay. Were there any other events when we were rolling a die that are equally likely? I'll give you a big hint.
Less than 5 and between 2 and 5.
Well, we'll take a look at what you're seeing here. Which one of these events are equally likely? Do you guys know 1, 6, and another 1, 6, and another 1, 6? What is this? Rolling a 4, like rolling a 1. Aren't they all 1, 6? So what do you say? They are what? These three events are equally what? Equally likely, yes. Were there any others in these examples that were equally likely? I think so. Were they? Yes, right here. What's this? Less than 5, between 2 and 5. What are they? How do you know they're equally likely? They're both what? 2/3. Good. Equally likely. Okay, you guys okay with that? Learning some language definitions, and they're everywhere. Everywhere. I can even, once you start learning this about probability and you start reading articles, those words pop out. You're like, oh my God, I didn't realize all this time all those words were even there in these articles. All right. Okay, let's go to another environment. What did I leave you guys yesterday with? Remember I said the deck of cards? Standard deck? Yes. Okay, let's get this here. Where's a copy here? All right. Oops, I'm going to erase this here. Okay, again, this is a standard kind of question here, okay? So what they're going to say too as well, they're going to say these things like this. I'm going to move it up here. Okay, erase all this here. Yes, a standard deck is when you throw out the what? The jokers. Now, just because you threw out the jokers, does that mean, what does this J stand for? Those are the jacks. Are they the same cards? No, be careful. Jokers are not the jacks. Okay? That's the first thing. Sometimes people say, oh, are they the same? No, you're throwing out the jokers. Another thing, I'm not sure if I mentioned to you guys this. This is going to be a factor. Where is your ace located? Where is the ace? Which cards are the aces? These A's, those are what? Aces. So if they're above the king, to the right of the, are they to the right of the king? That means the ace is what? High. So your ace here is what? High. Ace is high. Okay, you guys okay with that? If the ace was to the left of the 2, what do you think we say? Ace is low. Good. Good. Okay, now sometimes that's important to know and sometimes it's not. So I'm going to share with you guys how that's important to know. Okay, so we're going to answer probability questions. So here's what they're going to say to you guys. This is how they write it, or how you know I write it, but you select a card at what? At random. How many cards are you selecting?
1.
Good. How do you know it's 1? A. Okay, so far so good? That's all we're saying. You're selecting a card. Okay. Now, what are they going to say? They're going to say this. What's the probability of selecting question 1, a king. I'm sorry, let's do a queen. Okay? Standard kinds of questions, classical questions. You take a statistics course, elementary statistics, probability, wherever, anywhere in the nation, they're going to have these questions. Very popular. Now, why did we say that these are popular yesterday? Do you guys remember? Why do we say that these are popular questions? Okay. Standard deck. You guys ready for this? Okay. So what is the event, ladies and gentlemen? The event is what? Selecting a what? Queen. Okay. So what do you guys need to know? I'm going to write down notation this way. This is going to be P of what? Q. You know what that stands for? That's function notation. That's probability of selecting a queen. What's that defined to be? N of Q over N of what? S. Okay? So let's ask you guys this. You need to know two numbers. What are the two numbers you guys need to know? How many what? How many queens out of what? How many cards? Okay? So what do you have to do? You got to count. You got to have two numbers. How many queens are in a standard deck? Well, which cards are the queens? Take a guess. The ones that have what? The Q? Is that true? How many queens are in a deck?
4.
4? Okay, good. So that's going to be what? 4 out of, good, 4 out of 52? Is that true? How do you know it's 52 cards? That's the total in the sample, is that right? Because there's 13, what did we say yesterday? 13 hearts plus what? 13 diamonds plus what? 13 clubs, 13 spades. 13 plus 13 plus 13 plus 13 is what? What is that? 52. Could you use your calculator? Mm-hmm. Huh? 4 out of what? What does that reduce to? That's 1 out of 13, ladies and gentlemen. Do you have to reduce your fractions? Yes, ladies and gentlemen. So there you go, ladies and gentlemen. That's a probability question from a standard deck of cards. Jeez. What do you think? So what is it you think you guys have to go home and do? Look at this what? Study your deck of cards. Do you want to do it the night before? You know, I used to play organized sports. I used to play baseball. Okay. Anybody else here play baseball, organized sports? No? Baseball? Anybody here good at any sports? You guys know what I mean? How do you get good at a sport? Is it because you're a natural? You guys know what I mean? It's only people who are natural are good. Remember, I told you guys at one point in time, I never studied in high school, not one day. And so when it came to ELAC as a college student, I didn't even know how to study, and I was nervous and scared. Like, man, how do I do? I don't know how to study because I never studied in high school. But you want to know something? I was really good at baseball. So I used to kind of think about it, like, okay, how did I get good at baseball? You know what I used to do? See, and I remember this. Coach, when I was a kid, would say, okay, I want you guys to go home and practice. Whether it's practicing grounders, practicing throwing a ball even, practicing catching, just practicing. And you know what would happen? I'd go home and practice. I practice every day. So guess what? I became really good. I can catch a ball. I can throw a ball. I can fill grounders because you throw it against the wall and everything. I was good, and it just got better and better and better. And then there were some kids, you know what they would do? They wouldn't even practice. And so you'd show up game day to play, and what would happen? Well,